Now let's discuss SQL's use of XML schemas. An XML schema describes the structure of an XML document. And those schemas will assist XML parsers to validate an XML document by letting the parser know what to expect. If a schema is not available, a document needs to be examined twice. Once to discover the elements within the document, and then to process the document itself. Schemas contain information about the following items: elements and attributes that appear in the document, which elements are child elements, how many there are, and in what order in which they should appear in the document, details of the data types for both elements and attributes. It also indicates any default or fixed values for elements and attributes. And it specifies if any elements can be empty. All of the examples we've looked at thus far have been what we call untyped XML. An untyped XML is simply a column or variable that's not associated with any formal schema. And just like table objects have a formal schema definition defining their columns and data types and so forth, an XML variable or table column is referred to as typed when it's associated with a schema. And SQL Server will automatically validate any typed XML data against its schema. So, if for whatever reason a schema validation occurs, SQL raises an error. And SQL's Query Optimizer can use the information in that schema to process queries more efficiently. A schema will detail the data types for the elements, and the Query Optimizer can consider those types. Otherwise, without that information, XML is simply character data. So here's some key terms. Typed XML indicates that we're using a formal schema that'll define the structure, and we can use that to validate the contents. Untyped XML, it's not associated with any schema, so it can't be validated, and it lacks the ability to define its structure. This will cause additional overhead for parsers. In general, a schema itself is nothing more than a well-formed XML document, and in that XML document is a definition of the structure, data types, and constraints to which an XML document referencing it must conform. Just like there's a basic set of data types for relational database systems, the XML schema definition language, XSD, defines a set of base types. And these base types include what you might expect: string, numeric, Boolean, date, time. Let's take a quick look at an XML schema. Here's a quick example of an XML schema. You can see here that we're defining that there is an element that's going to be called warranty, and that warranty element is going to have a warranty period and a description, and both of those are string. We're also going to have an element called maintenance, and it's going to consist of a couple of elements itself, number of years, and description. Again, both of these are string. So while not a very complicated example, it does show you what we're talking about, which is the fact that we have the ability to describe what the XML document should look like, what data types it should have, and what elements should be contained within it. An XML schema specification will use lax validation for any elements using the AnyType type. In SQL Server 2005, that presented a problem because it did not support lax validation. However, beginning with SQL Server 2008, lax validation support was added, and that meant that formal validation occurred for elements that have schema declarations, but elements that didn't were ignored. So let's consider the following definition. Here we have a schema where we're indicating that we have three elements: an anything that's of type AnyType, then an element that's a string called name, and an integer called age. If we take a look at this XML, this validates successfully because the AnyType element is missing, it doesn't care, it's ignored. So that validates just fine. So let's take a look at this example. The following XML will also validate successfully, even though eye color is not defined. You can see that name and age is still defined, and that works just fine, but the any type is ignored. So let's consider one more example. We're using the same schema, only this time the validation fails. And the reason is our age element is defined as typed integer, but in the XML we've sent in a string. The next step in the process is to associate a schema definition with an XML data type table, column, or variable. Once SQL Server knows the relationship between the column or variable and a schema, it can validate the XML. T-SQL provides a create XML schema collection statement for this exact purpose. The basic syntax is the following. Create XML schema collection, we give it an identifier and we give it the expression. That identifier is the name that you provide to the schema collection, and the expression is any valid string or scalar variable of type varchar, varbinary, and varchar, and varbinary, or XML. And once it's registered, the XML columns and variables can refer to the schema for validation. For example, let's consider a schema definition and registered called mySchema. And how would we go about associating a column or variable? Here you can see we have the declarations, and what we learn is that if we place the name of the schema collection in parentheses after the declaration of the column or variable, SQL will associate it with that schema. Let's go take a look at a quick example. In this example, we're going to take a look at using the create XML schema collection statement to create our own user-defined schema. Here you can see we have the statement starting out right here. This is the name we're assigning to that schema. And in here we have the structure of what that schema is going to be like. And that's going to indicate what we should expect our XML documents that are associated with this schema, how they should be constructed. And very briefly, just to highlight a few things here, we can see that we are going to create a list of employees which consist of one or more employee elements, and an employee is going to consist of an employee ID and name. The name is going to be constructed, if you will, of a first name, middle name, and last name, and then we're going to put in a title for the employee, and then that sequence will repeat until we reach the end of our document. So what I'm going to do here is just go ahead and execute this to create the schema, and that completed successfully. Now if we come over and take a look at creating a table that's going to use this schema, remember that the way that we indicate that is after we declare our column using the XML data type, if we put in parentheses the name of the schema, it will now validate. So we'll create the table, and we'll then go ahead and insert some rows into that table. So our table was created, and now what I'm going to do is I'm going to insert a valid row into the table. Here you can see a single employee. We give it an ID. There's the name, the title, just as we discussed when going over the details of the schema. So we'll go ahead and execute that. That was fine. But now what happens when we place an invalid XML document into the table? The schema is going to see the error and throw an exception. And the exception that we're going to see is that our employee ID is not correct. It is not a number. We put some characters in there. But let's go ahead and fire that off, and you'll see that the XML schema validation failed. It's telling us exactly where it failed, and we can go back and correct the problem. Really nice things to have. XML schemas allow us to validate that data and makes your working with XML overall a little bit easier. Once you've registered your schemas, you might think it's really simple to view them, but you'd be wrong. SSMS doesn't expose that information. So in order to see the schema information, you have to get familiar with some catalog views and functions. When SQL stores a schema, the component information becomes part of the metadata. SQL does not preserve any comments, annotations, or non-XSD attributes. Using some T-SQL functions and catalog views, we can actually retrieve a schema that is functionally equivalent, but not identical to the original. So a tip would be, if you want to store an identical copy of your schema, consider also storing it as an XML data type column in your database. Then you can easily retrieve it and refer to it. There are several catalog views and functions available that allow us to retrieve information about registered schemas. They include the XML schema collections, XML schema namespaces, XML schema components, and XML schema namespace. The XML schema collections catalog view returns a single row for each registered XML schema collection. Here are the details of what comes back. We get a collection ID, a schema ID, the ID of the owner, the name of the collection, and when it was created and modified. XML schema namespaces is a catalog view that returns a row for each namespace defined by an XSD. So we get back the ID of the schema collection, the name of the XML namespace, and the unique identifier for that namespace within the database. Using the XML schema components catalog view returns a row for each component in each XML schema. That structure will detail the basic building blocks that comprise the abstract data model of the schema. Here you can see we get back a bunch of information. ID of the XML component within a database, the ID of the schema, the namespace, whether it's locally scoped or not, the name of the XML component, what kind of component is it? Is it any type? Is it a simple type, a complex type, an element? And here we can also see that we get some additional information, including a description for what kind it is. When you use the Create XML Schema collection or Alter XML Schema collection, it imports a schema. SQL Server alters the XML being stored while we said earlier it is truly functionally equivalent, it is in fact different. Some of the modifications that occur are SQL will remove any comments, white space, or annotations. Namespace prefixes are lost. Implicit type information becomes explicit. The purpose of the XML schema namespace function is to be able to reconstitute a schema. And the syntax is pretty simple. Let's take a look at the details. The relational schema is the name of the relational schema where the collection exists. The XML schema collection name is the name of the XML schema collection. And the namespace is the name of the specific URI of the schema to reconstruct. If not provided, SQL Server reconstructs the entire XML schema collection. Let's go take a look at how we use some of these catalog views. In this example, we're going to take a look at how we get information back about the registered XML schemas. The first thing we're going to look at is the XML schema collection. We're going to use that catalog view to retrieve information back about all of the schema collections registered. And here you can see they're listed there, and there's the one that we created in an earlier example. We're now going to take a look at the schema namespaces, and we're going to shorten the list a little bit by taking a look at those whose names contain the word resume. And let's take a look at what we get back when we execute that, looking at that catalog view. And you can see here we get one row. It's taking a look at all of the registered schemas and those that have a namespace with the word resume in it. Let's take a look at components of a specific schema. This one's a little more interesting in the sense that we define that employee schema a little bit back, and when we execute this, we will get back the information that is contained in it. You can see here, let me bring this up for you, lots of information about all of the components that build that schema. And with that information, SQL can go and validate the XML that is associated with that schema definition. And finally, we're going to talk about the XML schema namespace function. And remember, its purpose is to reconstitute that XSD. And what we're doing here is saying, go get me the employee schema that I defined a little bit earlier. And if we open that up, we can see there indeed is the XSD, but remember, it's functionally equivalent, but it's not identical. It's not the same as the string that we passed in creating that XSD. And so here was a quick example of how you use some of those catalog views to take a look at your registered schemas.